Let me introduce the last panel of the day with Lars Reger from NXP. A warm welcome. Martin Kroell from AUTOFLUG. Good to have you here. Kai Wackwitz from Drone Industry Insights. Good to see you. Olaf Otto from Siemens. He is new. He was planned and he shows. And Jochen Kaiser from Bauhaus Luftfahrt. Okay, so this is the last panel. We want to talk about what can technology do for flying drones or flying cars in the future, because we have the necessity to be secure and safe, to have reliable technology, to avoid and secure identification, to have a market approach, and to jingle with the numbers of what will happen. So this is what we see now. Please start, Lars, with your introduction.
Do we have a clicker somewhere?
Yeah, I think it should be here. Do we have? No.
I found it back there.
Ah, okay.
Okay. Yeah, so good afternoon, everyone. Thanks for being here. Let me quickly introduce NXP. NXP is the combination of the former Philips Semiconductors and the former Motorola Semiconductors. At the moment, we are the biggest chip maker for the automotive industry, and we have a portfolio, so electronics portfolio, that is broad enough to build complete electric-driven, autonomous, modern cars, really completely out of our silicon. Now, the key question is, of course, as we have to master the functional safety, and I call it functional security as well, can we use that electronics, these little Lego blocks, and get to the third dimension? So how do we get with our automotive electronics airborne, and can we leverage what we have anyhow developed? And I'm gonna run you quickly over that setup. So what are the key concerns in the industry, both in the automotive industry and in the avionics, in the drone industry, is of course, no one wants to have hacked devices. No one wants to have unsafe devices. And in the automotive industry, we call this functional safety, functional security. As I had said, we need electronics, we need a lot of software, we need a lot of systems know-how to deal with that. We want to have privacy ensured, but of course also autonomy. And just to give you one data point, former Freescale, so former Motorola Semiconductors, which belongs to us, is delivering a lot of the autopilot semiconductors in the existing airplanes. And of course with that, we try to leverage that in heritage over into consumer drones, but also commercial aircrafts. So just to give you a pitch on what these Lego blocks are that I was talking about. Well, of course, you have, like in a car, like in any robot, like in any IoT device, a sensing domain. How do you sense your environment? How do you basically get artifact-free data for your environment? Then you have a thinking domain. So how do you think of a driving advice? How do you think of a flying advice? Or in case of a Nest thermostat, how do you think of a temperature regulation advice? So we need a microcontroller, a brain, maybe sometimes a brain with artificial intelligence even. And then, of course, what we need to do is we need to send a command to the arms and legs of this robot, which is, of course, rotors, which is wheels, which could be a heating system in a house. Yeah? And we are using these electronics. So in the car, of course, we have interfaces for the wiring harness. We can use them here. We have very fault-robust CAN, LIN, FlexRay, and Ethernet devices, weight, state-free, very robust. We need to have powertrain management. Could be an electric drivetrain in a car, could be battery management in a drone, could also be the operation of brushless DC energy-efficient lightweight motors. We need to have the microcontrollers, the brains, so here for flight controllers, application processors, of course. But what we also need to master is we need to sense our environment. And just to give you one piece of, or one little data point, this is a radar sensor that we are using in cars. So 0 to 100 meters radar sensing detection. We can use this for autonomous parking. Google is playing with these devices, for example, for their self-driving cars, very successfully since 2-3 years. Of course, we can also use this for obstacle detection in drones. This radar system is able, so normally you think of a radar system, can detect a big block of steel. These systems are working like motion detectors. So they detect a big bag of water, and I'm nothing else than an 85-kilo bag of water with a couple of bones inside. So living object detection, you want to land a drone, you want to make sure that no one is hit by a rotor. These are the kind of devices. And of course, what you want to do is you want to sense your environment, and you want to have anti-collision avoidance. And I come to that as one example. With this tiny little chip, we can do that anti-collision checking. The crypto chips NXP is providing 80% of all the biometric passports, and if you have your wallet in the pocket, you are for sure sitting on a banking card with an NXP chip inside. We are using these crypto chips as well to making sure that, for example, things like the JPEG cannot occur anymore in future, but also, of course, you wanna avoid drone hacking. And what we try to do is with that silicon, we try to provide systems where drones can authenticate themselves. Just think of things like my hometown, Hamburg. We had the G20 summit some weeks ago. We have the London Olympics. There, the people had anti-aircraft guns on the buildings, tried to avoid terrorist drones flying in. With car-to-car communication, ranging over 1 mile of distance, we can do drone-to-ground communication as well. And the drone can basically, like I can go with my passport to the Lufthansa gate and say, I'm Lars, I'm allowed to fly here. The drone can say, I'm the CNN drone, I'm allowed to fly here as well. Yeah? And if it cannot authenticate itself, yeah, then you have to react. Maybe a sniper has to take that drone out of the air or whatsoever. But in principle, we are using always the same electronics, and it's developed for big mass volume markets. We can bring it into avionics. So what you see there is all these yellow blocks are the various areas that NXP has in the portfolio. And the funny thing was 2 years ago, NXP and Freescale, so those two semiconductor companies married. We have now this broad portfolio. Half a year ago, Qualcomm, the second biggest semiconductor company in the world, announced that they're going to buy us. So this is at the moment in the merge process. And these red to orange blocks there, Wi-Fi, Bluetooth, GPS, and also cellular connectivity, of course, are core pieces of that portfolio that are coming in now. So we have the Lego blocks really complete. And except from camera sensors and so really the optical sensors and some LiDAR systems, we have it all. So just to give you one example on what we're going to do is, I just said it, we have these car-to-car systems. We have basically Wi-Fi based standards. Within a couple of milliseconds, we can communicate over 2 kilometers of range, and we can tell other drones that we are close to them. So we have an anti-collision transponder. You know, for the ones of you who know the anti-collision transponder sizes of regular aircrafts, this is how an anti-collision transponder could look like, including authentication. So this tiny little chip is doing the complete job for a 2 kilometer drone-to-drone communication. We can have basically swarm flying with that. And yeah, just to give you one example, there would be plenty more. But I think time is already up, and we are good to go for the next presentations, and later on all open questions, of course, are welcome. Thank you.
Thank you very much. One short question. Without your products, let's say car-to-car or object-to-object traffic system is not possible, or you need these little gadgets.
Let's say it this way. This is, of course, not a monopoly of NXP. Yeah. This is an IEEE standard, and we just have these Wi-Fi standards, Wi-Fi derivatives. Yeah. Yeah? And that is working in mass volume. We have it in Singapore. GM is using this in cars. So basically, we can provide very cost-efficient type of communication systems. But yes, you need those tiny little chips. Yeah.
And it weighs nothing, so it's perfect for the modern world. So what can your product and portfolio give us to the dawn of a new revolution of individual flight systems?
I will see whether I can answer this. Thank you very much. Good afternoon, ladies and gentlemen. flying cars, drones, unmanned air taxis, urban unpiloted air mobility. The future is already today. We have already seen it this afternoon. You can see it outside. You can read it on the paper. These systems are flying. Prototypes, demonstrators are already flying. So technology is there, and we can already make something like a tick in the box. So that is already available. What makes it the big challenge? And in my opinion, the major two challenges for urban unmanned mobility is one, qualification, certification. How do we get unpiloted air taxis into the civil sky? With helicopters, with aircraft, with drones flying around over mega cities. How can we do this? How can we achieve it? That is probably one of the major questions, and I think we already have touched it this afternoon. And the second big question, and I think that is even more important, is the question of acceptance. So who here in the audience would enter an aircraft which is unpiloted and which brings you in a late October afternoon, windy, from London Heathrow into downtown London City, with maybe 2 or 3 other people sitting next to you, and you don't know how to fly, you don't know anything to do? Who would enter this aircraft? 1, 2, just a few people. And that's exactly how I feel. I'm from the aviation industry. I would probably enter this, but that is the major issue. It's acceptance. And when we go back and look at certification issues, qualification issues, and acceptance issues, then this brings us all back down to safety. Safety issues is probably the key word when it comes to unmanned or unpiloted air taxis. So what we have to bring into this industry is preventive systems in order to avoid accidents, in order to make sure these aircraft can fly in civil airspace. And of course, we have to talk about rescue systems. That is solutions, that is components, that is systems you never want to use. No one wants to use it, no one wants to see it, but we need to have it in case of emergency. Yeah, with a car, you can always stop, but what is stopping in the air? How can we deal with that in order to also increase acceptance using aircraft unmanned mobility? So when it comes to preventive systems, and I believe that my colleague from NXP has answered quite a bit on that, and I have to admit that I don't present any new products here on that. I've seen all these little tiny low-weight topics. Yeah, great for aviation, no doubt about that. But it's communication in the air. It's GPS-based topics. It's see and avoid technology in order to make sure that an unmanned vehicle is allowed and able to cross a mega city in low altitude. That is the main topic here when it comes to altitude issues. And when we are talking about see and avoid solutions, then it's also about sensing, intelligent cameras, communication, all these things. That is what we call, what we say when we talk about preventive systems. So something you need in order to make sure that you get safely from A to B. And when it comes to a failure, when it comes to situations you cannot control anymore, then we are talking about rescue systems. So what is necessary in order to get safely on the ground? We are providing restraint systems. We are talking about safety seats, crash-worthy seats. We're talking about airbags, not only inside the cabin but also outside of the cabin. Landing absorber systems, autonomous rescue parachute systems, all sorts of things that is helpful and that make sure that you get safely onto the ground. And that is a major issue in order to gain acceptance for this topic. And when it comes to all these topics and to this discussion, then it brings us to AUTOFLUG. We are dedicated to rescue and safety. Thinking safety, that is our core topic. That is a part of our company's DNA. Thank you very much for listening.
Thank you. They do it.
They do it?
Okay. Yeah, exactly.
Okay, thanks.
One last question, because when Frank had his panel here, we discussed aesthetical things and driving fast cars.
Yeah.
How risky do you live? And will you choose, let's say, an experimental flying manned drone for your personal transportation?
Yeah, I would certainly do that. But I need to know what is the plan B. What is the plan B? What happens if something goes wrong? And that is the most important topic. And as long as a system like that is in place, hopefully I never use it, but...
Okay, have the secure systems.
Yeah.
Thank you.
Thank you.
Now we are coming to the, let's say, market and business insights on how is it developing. Because having individual products is a nice view, but looking at what is coming up for a developed market is more than single products. We need a market perspective. That's what you are for. I'm very interested in to hear your part today.
Thank you very much for having me. Short introduction maybe. We are a small startup. We are a market research and consulting company for the commercial drone market. And drones have been there for a while now. They've been used in many ways in different industries and with great success. But what we encounter and what we see when it comes to urban mobility are the same patterns and the same obstacles here. It was a big topic to get commercial drones flying everywhere, out of sight, automated, and it will remain a large topic because technology evolves very fast and it's really, really difficult to make rules on a so quickly changing technology. Now, what does the whole drone market in our eyes contain? First of all, of course, it's hardware. Hardware, the main driver, technology as a main driver for this whole industry became very popular a few years ago, since microchips and sensors became very small and affordable. Based on that, a lot of people discovered the potential, said, that's great, I really want to use that, and put it into work. And a lot of people are doing this very successfully today, scale their business models very effectively by using drones because they're safer, they're quicker, they go places where you don't want to go or where it's very dangerous, and they do it in a shorter time than by foot. Software, very important. After people recognize that just flying a drone is not everything, you also have to have the infrastructure to use the data the drone captures. A drone can easily capture 10 gigabytes of data within 20 minutes. What do you do with all the data? Where is the intelligence out of this data? You need very, very good software to do this. Counter-drone, something that evolves within the drone market out of the urge that people are facing threats through drones. Today in Syria and Iraq, consumer drones are being used to drop grenades. It's very easy. And this threat is not just real in Syria and in Iraq, it can also be very real in the Western world. And so the counter-drone market is very, very interesting right now. It grows very quickly because there are a lot of security-sensitive areas on the ground which have to be protected from rogue drones in the air. And now, flying cars. Or as we call it, autonomous air taxis. We went for this term. We heard a lot of descriptions now, but we, just like drones, want to illustrate the future vision of what is possible with these devices. A drone, per definition, is something that is autonomous, that makes its own decisions, even has a swarm intelligence. And we, of course, want that for autonomous air taxis. Now, where does this market come from and what are the main drivers? The drone market is a melting pot, a gigantic melting pot from technology. And this melting pot is fueled by much, much larger industries. And the good news is here that these industries are producing technology at such a high volume that prices are rather low. So all these small sensors and all these small chips that you can use in drones today usually mainly come from the mobile phone industry and from the autonomous driving from the automotive industry. And there are some more mega trends fueling this melting pot even more. It's IoT, it's everything what is connected. A connected drone is much better than a non-connected drone. The same counts for AI, onboard processing for drones, and of course for VR. Now, philosophically speaking, what is a autonomous air taxi? Is it a flying car now? Some of them don't drive, so they are basically a substitute for a helicopter. You can not just transport people in it, so is it then a big drone carrying payload? So it's a bit philosophical. And to get to get a closer look at it, we have to look at the players that are out there in the market. So there are a few, quite a lot actually, and some of them are studies, some of them are flying today, which is really exciting. When you look at the timeline, there have been fundings earlier, but I just wanted to show you the last 3 years. You see some players here from China, EHang, that don't just build autonomous air taxis, but also consumer drones. We have Lilium with a big funding earlier in 2016, and of course other players like Volocopter, Terrafugia, and Aurora Flight Sciences. Now, what's so interesting? What about the partnerships here and the acquisitions? Geely, the very big car manufacturer from China, also bought Volvo. Now acquired Terrafugia to enlarge their portfolio. Aurora Flight Sciences partners with Uber to explore urban air traffic. But to make this possible and to bring this in line with everything we know from airspace regulation, a lot of questions have to be asked. Technical questions to make these platforms very reliable, safe for the people to fly in. And of course, I would like to add here, create overall acceptance. Only if people see the value in this technology, people will accept it. From a business point of view, you also have to add the affordability and the efficiency of these vehicles. And of course, you have to get it into an existing infrastructure, to get it working with other participants in airspace. And I'm really happy to be here and for the questions and the talk later on. Thank you.
You're welcome. Sorry, Kai.
Sorry.
Have you seen a working business model for, let's say, individual public transportation systems, something like a whole bunch of how it will be developed in the future to transport people by manned drones?
Not yet, not a business model yet. I think the very closest is the Uber concept. Yeah. They are very close. They made a really great job in figuring out how the biggest streams of people flow, what are the entry points, what are the exit points, and they made a really great scientific approach on it to figure out how big a vertiport, they call it, like a heliport, has to be to transfer people from A to B on the main routes. So they are very close to a real business model, but there are a lot of open endings out there, and it will still take some time to implement this. But this is the closest thing I can think of right now.
Yeah, okay. Keep it for the discussion afterwards. You all have the possibility to ask your questions after the full panel presentation. Olaf, great to have you here and to hear your inventive, innovative technology for bringing the things in the air, I think.
Sure. Thanks. I'm really happy to be here, and I just want to congratulate you all in the audience for sticking it out to this last panel. You've made the right choice, because I've got some information here that no one else outside of this tiny room will have seen by the end of the day. Some interesting information on our view of the market, so that should be a treat for you. My short overview for you is regarding hybrid electric aviation. When's the market? And just to sort of set the scene, what gets me out of bed in the morning, what excites me about this is the wish and the aim that aviation has a possibility to change. We're on a cusp of getting to something completely new, and it should be efficient, it should be individualized. You shouldn't have to sit in a big plane with hundreds and hundreds of people. You should be able to do this pretty much as you want it. It should be quiet, it should be emission-free, and it should be affordable and easy. And using electrification of aviation promises to do just that. What does Siemens do in that? We make very sophisticated, high power density hybrid electric propulsion technology plus digital twin technology. That's what you see at the bottom. So that's how we design all our systems completely in a digital format, test them out, rerun them, redesign them before we actually build them. This is what we have flying today. So electrical planes are not a thing that's going to happen sometime in the future. This is happening now. The picture that you see on the left-hand side of the screen, this is a smaller plane that is capable of being an aerobatics, an upset recovery trainer. The plane on the right, this is a very powerful one, and the picture that you see below it is actually shot from that plane when we flew it at Le Bourget in Paris this year, every day pulling up a glider of the French glider team to do a glider show. There are a number of areas that we have to address, and we've heard a little bit about safety, and that's a key concern. I have that in the middle here, certifiability, safety. There are two other areas, and that is storage, energy density. Obviously, if you want to fly, you need to have a battery that allows you to do that. And the last one is noise. There's some other areas of concern. I think we'll hear something in the next presentation about that. I just briefly want to touch on noise, and hopefully this works. And then you'll hear we've made a comparison between the big plane that I showed you on the right that has a 260 kilowatt electrical engine in it and its twin with a normal combustion engine. And this is what it sounds like. So as you can see, and you'll see on the next picture, you'll see the energy spectra, vastly different sound levels, and these planes and the propellers have not been tuned to be as quiet as they possibly can yet. So I personally feel that this is pretty amazing from a point of view of the difference that you get. And I think this shows that the promise that electrifying aviation holds in terms of making it quieter, and you remember the three problem areas that I showed you on the last slide, is just within our grasp. And that's what's going to enable part of the revolution to have these electrical planes flying much more extensively than we have them today, possibly also in urban areas. And that leads us to an overview that I want to just briefly put up there in terms of what we believe the market is going to do. So this is a view from our side in terms of the market for hybrid electric aviation, and it's split out. At the top you see what general aviation does, and for those of you that are not in aviation, general aviation is anything that doesn't transport people for money, so think smaller planes. And at the bottom you have commercial and military aviation, and split out. The light gray, that's fossil. The dark gray, that's what electrification is. It's actually going to start. It started already in 2018, but there is a huge potential, and the green box is actually where we think internally this is going to head. As a last slide that I want to show you, this is just in terms of the timeline. So this is summarizing the results that we're going to get for the three challenges that are being addressed, what we believe is going to happen in the years to come. And we believe that all those challenges in terms of noise, in terms of energy density, in terms of safety, they will be addressed, and we will see electrical flight, and we will see air taxis, and we will see a more personal mobility also in the third dimension happening in the next decade. Thank you very much.
Thank you. Have you ever flown?
I have.
Okay.
I have, and I can tell you from experience, it's great, it's fantastic. The only thing that I'm really waiting for is for things to become autonomized. I would happily sit in an autonomized plane. I'm a budding pilot myself, and I can tell you it can be a little bit hairy when you have to do 5 things at once. And I think, to be honest, computers will be able to do it much better than we will.
Thank you. Let's discuss that afterwards. Kaiser, happy to have you here, and give us your dessert.
Okay, thank you very much. Yeah, being the last in the row, I just want to give you some numbers and thoughts for dessert. Coming from Bauhaus Luftfahrt, which is a small research institute working mainly on future air transport technologies, we are more and more looking into these, what we call personal air vehicles. And the first thing we did was trying to analyze what different types of vehicles do we see. And there are many projects running around at the moment, not very much flying. We have heard a lot today, but when you take a deeper look, there's a clear focus on electric propulsion, but smaller systems with 1 to 2 passengers and more or less for short range. So everything is concentrating on city transport or close to cities. So what implications do we see on cities? What's going to happen? Let's take a short example, Los Angeles. We have a population of 4 million in the inner part of the city and about 30 million in the metropolitan area. And Los Angeles has a very busy airport with about 2,000 aircraft operations per day. Per day, that's the main thing. So what would it mean if we would start to do an air taxi service there? Let's make an assumption. We would say we would just add a taxi service, which is about 1% of all passenger traffic in most of these cities. We have an average number of 3 rides per day by every person in such a city. So, simple mathematics, we end up for the inner part of the city with about 5,000 air movements per hour. Compare this with the 2,000 of LA Airport. The whole area of LA, you will have a lot more flights every day. So this is quite a huge number, and nobody has ever seen this before. What else to consider? We need, for sure, for these kind of flights, some infrastructure. You need all the landing ports, not very much space, as seen in the Uber study, but you need lots of them if you want to do a real service. You need power supply. These things need electric power. You need all the communication installations with data communication for air traffic management. You need a certain reliability of service. What kind of capacity do you plan for? How much time for waiting and travel are people likely to see? And how do we ensure the interoperability with other modes of transportation, with public transport and cars? And quite often said today, automation or autonomy, nearly the same. We will for sure see pilotless operation, which is also quite new for aviation, at least for passenger transport. We need the air traffic management. Having several thousand flying objects in such a small area is something we need new technologies, databases to make sure that nobody is flying into any obstacle. Safety and regulation, also already mentioned, but regulation is one of the biggest hurdles for air traffic. And finally, acceptance, not only by the passengers, also by the people on ground. Do we want to have flying objects every few seconds above our head? I think these are the questions we have to work on, and I think we will discuss a little bit more. Thank you.
We all are happy to do that. Thank you. One moment. One single second. A last question. What do you think is the first thing we see operating in the air?
I think we will see, for sure, in closer time as today with volocopter scene, first types of traffic for just a few people. So a few people will be able to buy this service.
Yeah.
But for a real service for everybody, this will take a few years.
Okay, public transportation in that kind of dimension is not in your view now.
It's in our view. I'm quite sure this will happen, but it's maybe not that close as everybody is hoping for.
Thank you. So now I will open the questioning from you to the panel, because you have the possibility to do that. I'm happy to have some questions from you. We should have microphones, and I can try to bring you one.
Thank you very much. My name is Dag Schulze. I would ask you about the acceptance. What do you think, how we can do this in a democratic way? Because my impression is it's a new business field, and we had a growth dependence economy. And so for me, it's clear that it will come, and there's no democratic decision. How we can deal with this?
This, from my point of view, this is a real difficult thing. It's also part of culture, because every country or every nation has different culture to deal with these things. You have other nations like, for example, Dubai, where these things are taken very open. People are just using this, while here in Germany and Europe we see much more hurdles, longer discussions. So I think we are more democratic there.
One thing that you might see also is purpose-driven regulation. So look at London City. 40% of all the London City traffic is at the moment consumed by the Amazon type of small deliveries. If you have, let's say, commercial drones, let's say not on every balcony, but maybe from high-riser to high-riser, doing goods deliveries where you have dispatching stations and so on, that of course would really be a benefit for a city. You might get a purpose-driven approval for those. Goods, blood, so organs, heart transplants, super time-critical things. Of course, you want to fly in a city because population benefits a lot. But that is far away, of course, from all flights for everyone. Yeah? So that might really go in stages, and then, of course, also by region is very, very dependent on the population density.
And something to add, but because we have a similar problem looking at every stage of innovation every time. We had a meeting with some people from the automotive industry a month ago, and their perspective on drones were they are noisy, which means, yes, of course, cars are noisy. When I think on your propulsion and engines, the noise problem could be reduced. And then take the numbers, when we have 5,000 flights a day in a city or in a metropolitan area, there is a lot of noise still, even with the electronic
Right, and maybe I can add on to that. I think the challenge is whenever you have a technological change, then what does that mean to the population that is impacted? And I think that's the discussion that needs to be had. So it's very important from a point of view of, one, the people that are going to apply it, the users, and a lot of that is something that in the end comes down to a question of regulation and safety, but then in the end, the people that are going to be impacted by this technology, obviously there are a lot of people that will love this and that see immediate benefit. I think all too often the population impact is being forgotten. I think societies have been getting better about that, and that's something that especially on the noise front is being very, very extensively discussed, and so much so that, and Uber was mentioned earlier on, that Uber has identified the question of noise as the single biggest technological challenge that they need to address, and if they can't address it, they think that the whole business model will not work.
Okay, more questions to come. Sorry, then I have to come back to my own questions, and I tried to ask you beforehand. What is, from your perspective, the biggest challenge to get this, let's say, autonomous individual commuting traffic in the air to life?
As I already mentioned, I believe that the biggest challenge is acceptance, and it's not only acceptance from those who are entering these and who are using these vehicles, but also the acceptance of they're not working.
I don't know.
Is it working?
Are you? It's okay.
But it's also the acceptance of the people who are living in megacities. Yeah, we already can see today if you're flying around with a drone. We're already discussing today whether we should have something like a drone flying license. How can I secure people on the ground when drones are flying above my head? And it's not only about these little drones I can buy in a store, but it's 20 kilo drones, it's 50 kilo drones. So what happens if something crashes? Sure. That is, I believe, number one challenge. And the second one is certification. Air certification, how to integrate these vehicles, unpiloted vehicles, into civil airspace. And here the biggest challenge is not the airspace when I fly from London to New York. I think that's easy. But if you fly on lower altitudes from A to B within Frankfurt, within London, wherever, that is the biggest challenge. And that is a topic we have to answer, and that goes hand in hand with the issue of acceptance.
Maybe one thing that I'd like to add in response to a question that you asked earlier at the end of the last presentation. What do we see flying first? So I mean, obviously, drones are already flying, planes are already flying. I think the question then is, what do we see in the market first, and what are people going to actually use outside of research areas? And what I see from my vantage point at this time is that we will see actual aeroplanes flying first, and there are some very, very interesting use cases around taxi services in limited directions. The challenges with the taxi services today, when it comes to planes, they're too expensive and they're too loud. And those two areas can be addressed with a lot of the concepts that are out there, and I think that's what we will see flying first before we will see the vertical takeoff and landing applications, even though they are, more exciting. That's a little bit more back to the future. It's what they promised us. They promised us flying cars, so we've got to get there.
Okay, but flying cars was a promise given to my father in the 50s, 1950s. So that's not really new. And when you look at the pictures or we have seen, that is not an inventive idea to get cars in the air. The invention or the idea behind that is making air traffic possible for everyone. That is one point, and the other, let's do it autonomous, a free flight for all the people.
Whereas the core question there is, of course, aren't we seeing conflicting models? Yeah. So this model of flying cars is a model that was born in the 50s, where a high-end car was a status symbol still for most of us. Yeah. So if you have a Porsche car, my generation still thinks that big aluminum wheels, large engine, expensive car is the thing to have. For my kids, it's transport services.
Yeah.
If I'm looking at that, then that picture might totally change. And what I see is potentially bridging via an avionics service, some transport, getting close to Frankfurt. If I live as my parents close to the Sauerland here, 200 kilometers northbound, terribly to reach by car. But jumping over these type of gaps, autonomous services, and then reaching the city, and maybe not burdening everyone with noise here of my individual flying or whatsoever. So that might really lead to Uber-like hybrid models, and this is what I see. So the flying car might be an outdated model that we're seeing there.
Yeah.
And it's not bringing a car into the air. It's about flying an aircraft autonomously.
Yes,
Unpiloted.
indeed.
That's what it's all about.
Indeed. So cost
And
efficient,
no one of us will probably only very few people will own a flying vehicle, whatever it is. Yeah. We will use services getting from A to B.
Totally agree.
And that's exactly what it will be.
Do we see something like investments in ideas like that, building the bridge and focusing on the service idea and not the technical development of a new device?
Well, what you're seeing in automotive at the moment is there are strong pushes for autonomous vehicles coming from. Well, this is coming from the truck industry and from these transport companies, because there the cost of the driver is up to 30 to 40% of operating that thing. My private car is mainly idling around in the parking lot at home. So for me, the incentive for going truly autonomous for 20 minutes on average per day is limited. For these fleet operators, it is significant. So what I think what we are seeing is these type of models, Dubai and then all these melting pots at the moment, Singapore, they bring up, will be for these fleet operators, and we bridge it from there.
Yeah, exactly. And that in metropolitan areas where transportation is key for making business and living, and not for Berlin or Frankfurt. Still, no question from your side. Do you want to add something?
I would like to add another aspect of transportation, and it's basically the same thing what we see with commercial drones today. And I think the potential for manned drones or big cargo drones is the same here. And that is not densely populated areas with big congestions. It's rural areas like, I don't know if you heard in Mali and in Rwanda, there is a lot of drone traffic to bring medicals to very remote areas of the country. Reason here is that there are no roads, and it's very hard to get deliveries through, especially when they have a life-saving purpose. Now, this new technology gives the chance to leapfrog this whole process of creating infrastructure in terms of roads, just like they did in Africa with the mobile phone industry. They didn't put any landlines into every village, they just went straight to the cell phone. And I think that manned drones here can have a very great impact. And the question of acceptance here is basically no question, because it's life-saving. So people will accept this technology, I think, much, much easier, much quicker than the people here in the Western world complaining about drones flying over their heads.
Yeah, but as you see, a metropolitan area like Los Angeles has a number of problems when everyone is going in the air. Or,
Yes.
Right. So that is not the problem in regions without infrastructure, where transportation is key for living and surviving.
So I'd maybe to add on to that perspective, because we're now talking about regionality, and we had a question earlier on in terms of the democracy of decisions. I also believe that we will see a different speed of development when it comes to aerial applications. Right. And there are definitely regions in the world where a top-down decision can be taken and then things just happen. There are areas in the world where it's not as dense as maybe it is in Europe. And there are areas in the world where there is such an economic imperative that it will happen. So the one danger that exists, if we look at this from a point of view of industrial policy for Europe, is that we are at a stage where we are maybe a little bit too far advanced to gather the benefits of this impending change in a speedy manner, and that may not be the best thing, but on the other hand, we're trying. I think everybody's trying their best at the moment, and I think we've got some good chances there.
I agree, and I think we are a bit ahead of us right now. When we have this discussion of acceptance, you also have to picture the rollout of such a technology, and the technology as such is different from a regular helicopter today. But where does it fly? Where does it, does its job? It does this job within the given infrastructure. So what we see is maybe tomorrow we see an electric helicopter on a regular heliport and not somewhere in your backyard. So we will definitely use the given infrastructure to roll out this sort of technology and then increase this infrastructure by adding more and more vertiports or heliports or whatever you want to call it. So if you look ahead, you always have this dark vision of manned drones swirling around your head and landing in your backyard, but this will definitely not be the case. These things will have to fit in airspace and they will have to land on designated places, and these places are there today. So the rollout will be a rollout within the given infrastructure.
Waiting for questions.
There's a question.
Yeah?
There's a question over there.
Okay. Fantastic. I'm so happy.
Hi, I am Andrea, and I have a question, or maybe something to put in this discussion. Are you already talking to the cities or the people designing the cities or architects? So, because you just came up with this point that we think that maybe the plane or the drone is landing in the backyard. So I'm just thinking that there should be the communication already now to talk to the people responsible to plan our urban structures. So yeah, thanks.
So maybe I can add on to this one. So from our side as Siemens, we are not actively talking to cities yet, but again, there are companies that are doing that, and Uber was mentioned a number of times. They've actually taken it a step further. They have already agreed concepts in place with Dallas, Fort Worth, and with Dubai, and that includes zoning aspects, that includes the required infrastructure questions. So that discussion is happening, and I fully agree with you. I think the challenge that people will find is that the dust hasn't settled yet on what the final concepts look like. So at the moment, it'll still be a little bit of a little bit of an open discussion, I think.
And even in Germany, there's something like this going on. For example, in Hamburg, there's quite a large group of companies and institutes working together on urban aspects of drones and also on personal air vehicles.
Yeah, so just to give you one example, what we are doing as NXP, we are discussing with, for example, cities like Singapore. There is a big avionics maker located in Hamburg that is very active also in those urban areas. And of course, it's largely location or city dependent what you can afford. Yeah, Singapore has the big advantage that also you can go over the waterway, so not flying drones across densely populated areas. That's one advantage. What we are also doing is we have started what we call Hoover Games. So basically, we took all that silicon that I just showed you, have a little Lego-like kit for students, for programmers, for universities, schools, and so on, and give the people, we have it also for little autonomous cars, but we moved that to the third dimension. We have the invitation to all those developers to join us, play with the electronics, and become better, of course, on all sorts of private/semi-commercial drones, and try to learn from that, and also try to get a sort of a feeling what happens if there is swarm flying. Yeah? And I think we will see it evolving over time, but the acceptance will come slowly, if at all.
Yeah, please. Because what we see is trying to get ideas to reality, and that's punctual and experimental, of course.
Yeah, maybe a second question from my side. Why do you think about helicopter and airplane technology and not about Zeppelin technology, for example?
Okay, if, so I didn't say we weren't. So I mean, from our side, it's very simple. We're thinking about the drivetrain, and of course, you can take that drivetrain and you can put it into a helicopter, into an airplane, or into a lighter than air vehicle. And there are concepts out there, especially for transport. Again, Africa is a focus area. So yes, very good question.
So depends a bit on what you want to do. Yeah, getting your Zeppelin coming down on your balcony is of course a challenge, admittedly. Nevertheless, if so, I'm Hamburg-based. Yeah, if I'm looking northbound between Hamburg and or Germany and Denmark, at the moment we are planning to build a mega tunnel. Needed? Is it better environmentally to fly for the ones who are really under time pressure, and for the goods, okay, take the ferry ship? To be discussed, but there, of course, exactly the technologies that you're proposing make a lot of sense. So depending on what you want to bridge, how fast you have to bridge, and how your environment looks like, of course, Zeppelins are a pretty noise-free idea to go, yeah.
And I think it's been taken into account.
Yes.
It just depends on the need and on the application. Talk about cargo applications for Africa would make sense. Heavy loads make sense when it comes to urban mobility, urban air mobility. Infrastructure-wise, it's probably a bit difficult.
Okay, wir haben jetzt noch 2 Fragen da und da. Gerne. 3, wunderbar. 1, 2, 3. Danach müssen wir auch. Wir haben jetzt noch 47 Sekunden. Fragen Sie schnell, antworten Sie schnell.
I've no question. I'm from Airbus, and I just wanted to add to the question the lady had. So we're not only talking to Airbus, as it was just mentioned before, but we're also talking to architects that they should consider already, you know, these kind of landing platforms when they are planning high-rising buildings. Thank you.
There was a second question over there, and yours. We try to manage that in a minute.
We saw lots of these technology enablers coming from the military, like the drones, etc. Do you see the military pushing this individual air mobility, playing any role? Because it looks like it's a lot into the private hands at the moment.
I believe that the military industry or the defense industry is a bit more developed. Yeah? There's many more drones, heavy drones flying on the military side than in the civil side. So I think the civil industry can learn quite a bit from that. And there's just been, I think, a couple of months ago, a US drone manufacturer has just flown an unmanned air vehicle in civil airspace with a see and avoid application. That was quite amazing. I think we can learn from that and adapt it to the civil world. Yeah.
But on the other hand, the military world is not good in developing business models for
Mass production.
for the commuting the world. So
That's right.
Sorry. I hope you can give your question after that. Thank you for your participation. Keep DroneMasters in mind. We have regular meetups every month. The next one is in Berlin. You find us on our website, DroneMasters.com. And I have to announce a short break till 7:15. That's all. Thank you for the evening.